Welcome back. Um, we are learning about the medium access control protocols for otherwise exclusively designed for the mobile ad hoc networks. First of all, we learned about the issues that has to be addressed while we are designing the mobile ad hoc networks. So the key points that has to be considered include the bandwidth efficiency, utilization, and then quality of service, synchronization among the nodes, and few more issues that has to be considered is the error prone, otherwise avoiding the interference. So we have a shared broadcaster channel. So how can we utilize that in an optimal way by avoiding errors? And then the distributed nature of the mobile ad hoc network that has to be considered, and also the mobility of the nodes in the mobile ad hoc network. These two are the basic characteristics of mobile ad hoc network. And the common problem that happens in a wireless communication are the hidden terminal problem and the exposed terminal problems. So all these problems has to be taken into consideration while we design the mobile ad hoc network medium access control protocols. So already we have learned about the hidden station problem and the exposed station problem in the previous slide also. Here comes another example. The first picture in the left hand side is an example of the hidden station problem. So what happens here, A wants to send to B, but it cannot hear that B is in the transmission because C is already transmitting, so that the broadcast is being there throughout the range of C, and hence A, even if A wants to send, it doesn't know that C is being transmitting because maybe B is in its communication range. So if B starts communicating, C will know. Since C's range is not up to A don't know that C is communicating. What happens? A will start transmitting, so its bits will get collide with the already transmission that's happening. So there will be data loss. This is the hidden station problem. And the next picture on the right hand side is an example of the exposed station problem. So here A is starting a transmission to B. Okay. But B, even though B has some data to send to C, since A has started the transmission, B will mistakenly think if it sends a data to C, it will also enter into interference. That will lead to data loss. So that is called as the exposed station problem. Now we have seen these issues in the wireless communication, especially in the mobile ad hoc network. Now we are going to design the medium access control protocols. So what are the strategies to be considered? These are the listed points or the strategies, otherwise called as the design goals, while we are creating the medium access control protocol. The first one is the nodes are distributed, which means there is no centralized control over it. Likewise, the MAC protocol, otherwise the medium access control protocol, also works in a distributed way. It doesn't go under any particular controlling entity. And the second one is it has to provide the quality of service support for the real-time traffic. When there is a live traffic, live broadcast happens, otherwise some video conferencing. So for such things, the data has to be reaching the destination appropriately, as well as the flow of the data also have to be perfect. Hence, quality of service is an important entity to be considered. The third point is the access delay. How exactly the transmission of the packets is happening from the source to destination. So it cannot enter into some latency that creates or that hinders the throughput at the destination end. So access delay has to be minimized. Then comes the bandwidth utilization. As we know that there is a common bandwidth available in the channel, and that should be optimally utilized by every station. So also it tells about the fair allocation of bandwidth, which means so we are giving some priority to real-time traffic. We cannot give such a priority for any station for a very long time, which will affect the allocation of the other bandwidth allocation of the other stations. Hence, some strategy has to be designed in such a way that the bandwidth is fairly allocated among all the stations. Then comes control overhead. Now we are going to learn about some strategies like RTS, CTS, request to send, clear to send. Those strategies are the control messages. So they will support these medium access control protocol in order to avoid the previously mentioned issues. But we should not trust too much on these control messages, so it becomes an overhead to the overall transmission. We should avoid that. And next comes minimizing the effects of hidden and the exposed terminal problems. So we have to, every strategy must find some solution to avoid these two problems. And then comes scalability. Our protocol should be designed in such a way that it must be scalable for larger networks also. So for any number of nodes, it should be able to cope up for the growing number of nodes in the network. And the next one, the design goal says adaptive data rate control. In the traditional protocols, we will be dealing with some constant data rate. Since here we have mobile nodes and also there is no fixed infrastructure, we will be facing, the mobile ad hoc network will be facing too much of adaptive data rates at many times. Hence, a protocol should be able to handle or control the adaptive data rates. And the last one is synchronization among the nodes. As we have already seen, synchronization is also dealt as an issue in the a common issue in the wireless communication. So how can we deal with this? Our protocol should be able to send some communication between the source and the destination so that they both are in the track of sending as well as the reception. So when both is happening simultaneously, then only the data loss will be avoided. So these are the design goals that has to be considered before we design a medium access control protocol for mobile ad hoc network. So it includes considering the all the characteristics of the mobile ad hoc network as well as the common issues that will happen in wireless communication as well. Now let us see some of the classification of the medium access control protocol. As you can see here, the categories of the medium access control protocols for the ad hoc wireless networks is given in this picture. So we have four basic categorizations, of which the top three are the major ones that is contributing. The first one is the contention based protocols. They don't have any fixed scheduling or reservation, but the stations will contend with its neighbors or they will compete with its neighbors and they will start the transmission. So it is a kind of random working protocol. So whenever it generates data, what it will do, the station will try to compete with the next station. Before it sends, the first station will try to send the data and hence the data transmission will happen. Whereas when you look at the second categorization, it tells contention based protocol with reservation mechanism. For example, when you go for real time traffic like voice and video that's happening in live data transmission, live broadcast, at that time what happens? We have only a common shared broadcast medium In that, this particular real-time traffic is has got a higher priority. So for such prioritized task within the common broadcast um, radio communication channel, some reservation can be, some time slots can be reserved for such communications. So that's the second classification, contention based protocols with reservation mechanism. And the third category says contention based protocol with scheduling mechanisms. As the name says, so it is having some scheduling. So based on some strategy, this can be, it could have been divided into some time slots, so and so on. So the first station has to participate now, and then comes the second station. If there is any priority comes, they have to be given a higher priority. So likewise, the stations will involve in some scheduling mechanisms, and then it will start the transmission. So apart from these, any other concept means it comes under the other MAC protocols. That's the fourth category. We are going to learn in detail about all the subcategories of this classification and also some example protocols under each of the categories. So stay tuned for further videos about detailing the classification of medium access control protocol. Thank you all.